So she starts with you 5 here. I mean, could I ask, where are you in school? What are your majors, if I can ask? Aaron, are you a physics major? Or?
Yeah, I'm a physics major. After this semester, I'll have 9 courses left.
Oh, yeah.
And I'll have a minor in astronomy.
Yeah.
You know me, IT major, but I'm going to be finishing my bachelor's soon, like this semester.
Oh, yeah.
And I'll be doing my master's in software engineering.
Oh, okay. Yeah.
I'm a comms major,
Oh, what?
a communications major.
Oh, okay, right. So,
Mechanical engineering. I'm going to try to go for my minor in physics.
oh, okay. Yeah.
I'm a physics major. We
Okay.
have like 1.5 years left.
Oh, yeah. And what are you think about doing something in astronomy? It is an extraordinarily difficult field to get a job in, so.
It's not what I heard.
Oh, yeah?
Yeah, I heard it's like 100%.
Okay, good.
Yeah.
I would love to have a job like in IT that had some type of deal with astronomy, maybe, I don't know, I build websites mostly, so maybe building astronomy websites would be cool.
Yeah.
Something like that, because I've always been a fan of, astronomy, and I took physics 1, so I mean, I'm not horrible at it, but obviously IT majors, we only have to take up to calculus, so.
Mm-hmm. Right, so.
A little bit less.
Yeah, I was telling Aaron a while ago that I understand that astronomy largely these days is very software based because people, take Horsehead Nebula or,
Exactly.
any kind of thing like that, and they take, in the old days it was like, take a photograph,
Yeah.
but now it's like take 100 pictures and stack them up and
That's
things
the
like that, and
Yes.
brighten them and things, so you can see stuff like
Right.
detail and nebula and things like that, the colors that you could never, ever see before, so.
That's one of the reasons I'm looking at software engineering, right? Because I want to learn, I know web development, I can do web apps, all that, but I want to learn software, and I've taken some astronomy classes and things, and hopefully I can find something that correlates, software engineering. It'd be great.
Yeah.
It'd be great. That'd be my dream job right there. 'Cause
That's
I love
fantastic.
astronomy, and I love software. I love computers. Ever since I was a kid,
Mhm.
I was always great with. I love space and I love computers. Honestly, things I love.
Oh, yeah.
I'm becoming visual art. Visual art.
Well, like astronomy is?
Yes,
Yeah.
I'm the visual art,
Mhm.
not theory.
I still use a 20-year-old doll.
Yeah, well,
No tracking, no.
yeah, I'll talk a couple seconds here. I mean, I do some fairly respectable astronomy, really satellite tracking, And this is a used camera I got I think the camera costs like 150. It's all, I really wanted it dedicated to, wanted to prove that I could do a lot of stuff with inexpensive hardware and software, stuff like that, And the lens is a bit more expensive, like 170, something like that, It's only a 50 millimeter lens, so I buy my camera stuff at like Houston Camera Exchange, which is, I don't know if y'all know much about cameras or whatever, but new cameras are expensive, but they very rapidly, like all their kind of technology. After a couple of years, they give the damn things away, So,
Same thing with
I got a
any technology.
I got a D3200 I bought in 2012. It was $1,200 back then.
Oh, right.
Now you can get them for like $200 or $300.
Oh, and if you went to Houston Camera Exchange and sold it, they'd give you a couple $100 for it.
Yeah.
So I sold a lot of my old, film.
Yeah.
I had a lot of film cameras I sold several years ago over there. Lenses, I've spent thousands of dollars on
Lenses
them,
are
what I mean?
expensive.
And then,
Buy the most expensive part.
Yeah.
Yeah.
All right.
okay, ready?
Yeah, let me give some
Oh, yeah.
announcements real quick. Hey, everybody. All right, so things coming up. I was supposed to have I'm turning this off. Better. Okay. I was supposed to have a treasurer's report. Don't quite have that right now. But we made like $160 for the bake sale. Spent about 50 on supplies for this upcoming event we got. It's a solar system lot. It's 1 to 1 billionth scale. So we shrink all the distances and all the planets down to really small. And then we're going to start here. We're going to walk on campus and put everything into perspective for everyone. That's coming up on the 1st. We'll meet in here at 1 p.m. And then the 3rd, we're going to have a second one for those that can make it that day. Meeting here at 5:30. It'll be cool. We'll hand out stuff, and everybody can participate with us doing that. And then JSCAS is going to be meeting November 10th over in the auditorium room. That's 7:30, I do believe. 7:30. Yep. And then we're supposed to have, Dr. Masood's having a star party on the 7th. That's from 7 p.m. to 10 p.m. JSCS will be here. It'll be out by the dumpsters again, out by the loading bay. And then on the 17th, we're also going to have a meeting in collaboration with SACNAS. And they're going to do Native American or Indigenous American, or maybe just Indigenous Peoples astronomy. And that's all I got. You got anything? No? That's it. That's all I got. Oh, and today's presenter is Charles Phillips. I'm sure he'll tell you all a little bit about himself.
I'll spare you long and dull career path.
Give us the long and dull we love.
So, how do you open this up and all that? And
Oh,
I'll let you do that.
I got it.
yeah, you just, you want to do the clicking?
Yeah, I'll do the clicking at least.
So you wouldn't mind, yeah. Somebody like lean out to look at
Yeah,
it.
yeah.
Falls under the job description of director of
I'm
technology.
Well, you can figure out how to.
Next, you want to make it bigger? Or full size it?
Does this work already?
Yeah. How do you make it?
Then you just like, yeah, there it is.
That's why I'm not that guy.
Yeah, exactly. So, I will give you a very brief. I started in satellite tracking in 1978, which I'm sure for all of you seems like the dark ages, and it was. Does anybody know that there are, of course, we all know that there are like millions of satellites up there in orbit, right? You know, and does everybody know that the U.S. government somehow, back in the good old days, stumbled into being the people who list all those satellites? Every satellite has a satellite number. It has what's called an international designator or a COSPAR number. It has, there's a big list online that shows all the satellites that we really actively kind of follow, and sort of like where they are and stuff like that. So anyway, let's talk about this. So, I first start off by saying the U.S. government and every other government also, well, not all of them, not Nepal, a lot of the governments track satellites. Germany does, Russia certainly does, China does, something like that. Okay, and so they all know where many of these satellites are. Okay, but then there's a group of amateur people. I'm a member of this amateur group, and a lot of them live in. One guy lives in Germany, the Netherlands. One guy lives in India, South Africa, stuff like that. So there's a group of people out there who track satellites, and I'll tell you why in a couple seconds as well. I want to show you sort of like how they do it. And the amazing thing is, in spite of the rotten viewing and the rotten skies we have around here, we can actually track satellites from Clear Lake, which is amazing. Now, let me ask quickly, am I on camera or whatever? Is that a camera? I should look at once in a while.
They can't see you, they can just see the screen.
They just see the
that's
screen.
fine.
So you're
that's fine. Okay, let's
Go back.
let's go back. Let's go back to start first, okay? Because that's not the first one. Okay, right. So part of the reason that some of us track satellites is this object right here. When satellites get fairly close to the ground, when part of the orbit, when the low part of the orbit gets to like 85 kilometers, it's essentially going vertically. Okay, so it hits the atmosphere, it slows down and hits the ground. And pieces like this hit the ground, in many cases, substantial pieces. So, okay, next slide. So the big reason that some of us amateurs track some satellites is that they have this big list of satellites in orbit, and the US, the Space Force nowadays, tracks all of them and predicts, and they warn people on the ground when these satellites are gonna hit the ground. And they could be substantial pieces of metal. So far, we have one documented person who was in Oklahoma who was actually hit by a re-entering part of a satellite, but fortunately, it was a woman who was hit by a piece of very light insulation. So maybe other people were hit by satellites, I don't know, but we have one documented case, but it was not heard. Now, people had satellites crash in their houses and things like that. That's not too unusual. Okay. So my contention is that when the US government, back to
Oh, my bad.
okay, knows that something is going to hit the ground, we ought to tell people. You know what I mean? And in fact, in quite a while back in 1978, I was in a job, and part of our job was we people actually ran that alerting system. Anyway, but in November 2015, people in Spain saw this re-entering object and said, "What is this?" You know what I mean? So it was a Centaur upper stage that launched by the US. And here's a story about that if you want to hear about that. So people saw this thing was re-entering, and they checked the standard warning pages and said, there's just no notice. Okay, next, please. And so significant pieces, this is a composite overwrapped pressure vessel here. And it was fairly near Madrid, Spain, unfortunately in some farmer's field. Okay, next, please. Okay. So, I'll point out. So we have objects in space which are re-entering, and a few of them, not many, but a few of them, there's no notice, and these things hit the ground. Now, they could cause problems. We have not known what happened yet. So let's back up. So let's look at this satellite list, okay, called the satellite catalog. This is an example of satellite catalog that I printed off. So the Space Force has this catalog. They are in California, right by the California launch site, Vandenberg Air Force Base, or Space Force Base now. So they track all these thousands of objects, and they put all this stuff on the web, okay? So there's a lot of orbital, and I have a slide of orbital parameters later if you want to look at that. We have parameters such as the period. In other words, the number of minutes it takes the one object to go around Earth. The inclination, okay, angle between the planet or the equator, equatorial plane, and the satellite's orbit plane. Anyway, so the satellites have names. They have international designators, also called COSPAR numbers. They have, I didn't print the satellite number, but that's all right. And so they have the US, the country that owns them, stuff like that. But it has parameters, inclination, 63.39. Period, 87.54 minutes, stuff like that. But there's boxes that are empty because there are some of these launches and the associated spacecraft that are national security spacecraft. In other words, they're like the photo satellites and E-Link satellites and SIGINT. We talk about that all day long. So the U.S. government for a long time has not released the parameters because they don't want the bad guys who will track it. Okay, and it's sort of they started something they really haven't done a very they haven't done a complete job. They haven't really looked at it. There's actually a bunch of French E-Link satellites which are long ago have died, and they have a certain lifespan. They've expired. Anyway, so there's French satellites. There's those three small constellations of French satellites. They don't show those on the orbital parameters. Don't show those on the satellite catalog. And there's Japanese and stuff like that. So the idea of not showing the orbital parameters back in the good old days was a good idea, because back in the old days, like the Soviets, still like that, the Chinese didn't have, the kind of the distributed radar network that we have and things like that. They couldn't reliably track them. So the idea was that, like when a photo satellite flies over, Baikonur, it's Chiratan, Baikonur, or Russian launch sites at the time, Soviet like Plesetsk, or they flew over Chinese sites like Lac Nor or something like that, we could take pictures and they wouldn't know to cover them up. Of course, that's everybody has lots of coverage nowadays. That's sort of an old idea, but the Space Force really hasn't kind of caught up yet with reality. Okay, next slide, please. So some of these satellites are up there, or all satellites eventually will re-enter, right? A lot of them a long time, okay? So the Aerospace Corporation, which is a group which kind of Air Force or Space Force pays them, they're a kind of old graybeard smart guys hanging around, They have a major notification site there, CORDS. The Space Track is a web page. They have re-entry predictions, mainly for stuff that's not going to hit the ground, like lots and lots of little satellites or small enough that burn up, So, and we showed that page, a little short screenshot from the satellite catalog with all those satellites with empty boxes. So one of those had parameters shown, most of them did not. Here, thank you. So that's not an off-the-book satellite. Of course, it did decay and hit the ground in 1999. But there's one that decayed and hit the ground in 2000. Still, they don't show orbital parameters for it. But okay, it's next. So here we go. Right. So in the official warnings, these off-the-book satellites are not shown, even though they may be French, they may be Japanese. You know what I mean? So there is a group of people, and I won't give the whole background, amateur people, some of them are actually professional astronomers in addition. So there are other groups that maintain satellite catalogs of their own. Okay, next page, please. Okay, so this is the only real eye chart here there. So, So there's a group of astronomers that I'm a member of, and we track these satellites. It's fun. I don't know, for not everybody, I'm sure, certainly in our area, so I track optically with this camera, which is not easy in this area at all, you know what I mean? So what I do is, and I'll show you how in a couple seconds, I take pictures of satellites as they go overhead. Now, fortunately, most astronomy is done in the middle of the night. For instance, you're doing like comets, you're doing a lot of the Perseid meteor showers and stuff like that, early, like 2 a.m., 1 a.m., stuff like that. Fortunately, doesn't apply. And I can talk about that in a couple seconds if you really want to know. You can only get photographs of these satellites in the dawn or dusk, okay? When the ground is dark, and yet the sky is the sun still lights satellites above you. The sky, there could be 400 kilometers up there, which is like ISS, like 450 kilometers, which is like 320 nautical miles, up to nautical miles, kilometers, Anyway, so where the sun is illuminating satellites in space, but the ground is dark, so you don't have all the sky glow and air glow and, stuff like that. So it's a fun challenge. And what I do is I take pictures, I'll show you how in a couple seconds here. And astrometry is sort of like astronomy, but imagine, I'll show you a couple seconds here, a picture. So astrometry takes like a photograph or image and assigns right ascension and declination to every point in that picture. And I'll explain in a couple seconds here. So we'll run through astrometry software, and then there's several other ones I use. Smithsonian Astronomical Observatory, SAO, Image DS9. I can sort of show you something over here in a couple seconds. So you run through a lot of software, and I get what's called observations, okay, which is the time of the observation, right ascension and declination of so it's a essentially vector from the center of the Earth to the satellite at a specific time. So, and there's a guy, Mike McCants, who happens to be in Austin. He's been around for a long, long time. So we get all these observations and we email them to him. And then Mike runs all these observations from people like in India and South Africa and the Netherlands and Germany and something like that. But
Ukraine.
well, I'll talk about that in a couple seconds. I was trying to get them busy. They're kind of busy right now, so if they would, you know, I was talking to Max about that the other day, but, so we all email our stuff to Mike McCants, you know, and he runs some magical software and produces, you know, I heard it's called a 3-line element set or 2 element set or TLE.
Yeah.
But, it's a list of orbital parameters that kind of, I don't want to get into that right now. So there are many kinds of satellites that we track. Many of them are very near Earth and very bright. You know, I typically track these satellites, which are called the Future Imagery Architecture. There are some fairly low, but orbit like at, you know, 350, 400 kilometers or so. And they're US photo satellites, and some that were like radar, like synthetic aperture radar, and stuff like that. So they're very low and bright, and very excellent if you're learning to do it. They're the ones to do it in, you know, this area. There are some of the, you can't track all the stuff, but there's a lot of stuff like NOS is a US naval ocean surveillance system satellite. They travel at 800 kilometers, 800 kilometers or so. They're considerably dimmer, of course, you know, than these. I track these really bright ones.
I've seen a NOS
Oh, yeah. So
traveling in the triangle.
the old ones traveled in 3, exactly. Right now that they said 2. They travel in pairs. You know, it's since they were able to get the critical thing is to be able to get the onboard clock to run very, very, very precisely. You know what I mean? But anyway. So we track the NOS satellite. A lot of people really love those NOS satellites. They're very predictable. I personally think they're very boring, you know what I mean? And there's a bunch of deep space stuff, as we, you know, there's very different definitions of deep space. I'm kind of using the Air Force or Space Force definition. But don't you know what a semi-synchronous satellite is, like a Lunaya? It's a satellite who goes around the Earth just 2 times per day. And I'll talk about that in a couple seconds here. So like the ISS goes around 90 minutes or 95 minutes, something like that. So about an hour and a half. ISS will go to Earth in about an hour and a half. A lot of satellites go 3-4 times, you know, per day, or, you know, that's a whole quite a variety of orbits, you know. So I'm not going to get into that too much right now. But so there's a lot of stuff that's way out there that the group does track. Now everybody's familiar with geosynchronous satellites, right? Who appear to like hover over the Earth's surface. As Earth, they turn the same rate we do. So a lot of people track geosynchronous satellites, which also, to me, a lot are dimmer, of course, but they're fairly boring because they don't move, you know, stuff like that. For us, you like point your camera and get pictures. And the really, really bright ones, the U.S. has a lot of really bright ones, like giant antenna, but they're over the Russia, they're like geosynchronous, you know, so they can look directly up into Russia and China, so like that. They're ELINT, the electronic intelligence satellites. So and we just track a lot of stuff that, of course, the U.S. government and of course the French government, the Japanese don't announce. Israel doesn't announce the mission for some satellites by tracking them. If you get orbits, you can compare them to things, and then kind of we can speculate about what the mission is. And so people that are doing this, Ted Moltson's in Canada, Kees Bassa's Netherlands, Greg Roberts South Africa, stuff like that. Was one success we had a couple years ago, you know. The U.S. government launched something called SensorSat. And if you all are familiar with many of the satellites that like the inclination, and I'll talk about that in a couple seconds, the angle between the Earth's equator and the orbit of the satellite, you select an inclination for many, many different reasons, right? Well, SensorSat was a very unusual one because it was launched at near zero inclination, which is very rare. But the idea was, it's essentially a telescope looking directly up as it flies around the equator. It was basically like checking up on all the geosynchronous satellites above it, you know? So they didn't announce the orbital parameters that satellite ran first, and we were able to kind of figure out where it would be. And Marcelo, who's in Brazil, was able. You really have to have a very low latitude place to track, stuff like that. It's a fairly low, that, again, like 400 kilometers altitude, zero inclination, so it had to be right essentially near the equator to see it. Anyway, so there's a lot of people that do much more tracking than I do because they're in better, locations than I am. You know what I mean? I typically do analytical astronomy, so I take all these, all the results of other people and mash them together and then analyze it and figure what's going on. Okay, next please. And so one fun thing I've done, I'm not sure everybody would think this was fun, was take a look at a bunch of satellites which are going to re-enter and then predict where they're going to re-enter. Now, most satellites do appear in the normal, web pages that announce the re-entry. You've probably heard about, like, the Chinese have been very bad about launching these giant first stages, which are in orbit for a week or a week and a half or so, then re-enter. They dump like tons of stuff on the ground. Unfortunately, everybody knows that most of the Earth is covered by what? Water. So most of it go in the water. So, but they have had plenty of satellites re-enter and hit the ground. Anyway, so what I do for several of these off-the-book satellites is I plot what's called perigee. That's the lowest point. The lowest point of the orbit is called the perigee. The high point is the apogee. Now, something like ISS is a very circular orbit. Perigee, apogee, nearly the same. But many of them, perigee and apogee, are far, far different, So, and some of the off-the-book satellites have very low perigee, very high apogee. And I track those. The interesting thing to me is normally the orbits get smaller and smaller. Do you want to guess why the orbit gets smaller? For like ISS, what makes the orbit get smaller over time?
Drag.
Drag, exactly.
Yeah.
Hits the atmosphere.
Yeah.
So every time it goes to the atmosphere, it goes to the air, it's friction. Frictional forces slow it down. So a lot of these satellites with very low perigee and a high apogee, in other words, very stretched out orbits, they experience a lot of drag at perigee and none other parts of the orbit. And so it's very unusual that most orbits, perigee and apogee, like ISS, the perigee and apogee will only ever get smaller until, of course, they fire engines bigger. But if you have a satellite that doesn't have an engine, like a used rocket body upper stage, the apogee and the perigee will only get smaller and smaller and smaller over time. Okay, now these are satellites that where the perigee goes up and down, but it's not because there's thrusters on board. Okay, it's not because they're sort of an engine and getting the perigee bigger. It's a effect of the moon's gravity in the orbit, and I can talk about that. It's the Kozai effect, or I forget the other guy, Lebedev, Kozai effect, whatever. But for some satellites with very high, they're very stretched out orbits, the perigee actually sinusoidally varies just due to the moon pulls the orbit and pulls the perigee higher. So anyway, so for people that track satellites, it's very interesting. Okay, next slide. Oh, fire.
Can I ask how much does the moon pull it out? Is it
Actually, quite a bit. I mean, this here, here's like, we can't read it to the here, like, this is like 200 kilometers or so. That's like, 225. So 25, that's a fair amount.
Yeah, wow.
So, and here, like the low point, this is getting really low, it's like 180 or so, up to 400.
Wow.
So the moon can actually,
And the moon's doing all of that right there?
oh yeah.
Wow.
There's a little bit of effect due to like the sun and things like that, you know what I mean? But, and I really don't have the numbers on that. Somebody probably does someplace, but, yeah, the moon is the big, thing that changes orbits around Earth other than the atmosphere. Okay, next. So anyway, most of the time, satellites which are going to re-enter hit the ground, they come out in those prediction web pages, and somebody like, they can actually warn people, look out, but there's some that have not. Now, the other thing, a lot of these satellites where the apogee is very low and the perigee is very high, or vice versa. Perigee very low, apogee very high. Their perigee is fixed in the southern hemisphere. Oh, I'm turning my camera. There's a bunch of satellites, so geosynchronous satellites. I'm trying to, if it get too far ahead of you, let me know. So geosynchronous satellites would be right over the equator, okay, and they can see the ground below them. But let's say you want to have a geosynchronous satellite and you want to see like this area up here. They have some satellites with they're very low perigee but very high apogee. But the perigee is over the southern hemisphere, and they go up. They're called Molnias or tundras. Molniya was a Russian system, which one of the first ones you'll talk about a lot is Molniya's lightning in Russian. And their communication satellites, you go to communicate. So these that orbit is very popular with like Norway, Russia, Canada, stuff like that. You have an almost geosynchronous communication satellite over that part of the Earth, so that's very handy. And then there's all kind of people that are putting satellites in that kind of orbit. So frequently called a Molniya. But anyway, so with the perigee over the southern hemisphere, typically at the perigee will up and down, up, down, down, and eventually you'll get down to the like less than 100. Okay, here.
So to get it at geosynchronous, do they have to send it out further so it travels? Because you got to travel a certain distance to be free from
Yeah,
free fall. Do
so
they
the
send it out further, so it kind of has to travel a bigger circle.
you mean to now you're talking about like geosynchronous over the equatorial, or you're talking about like
Or anywhere.
well no I forget what the altitude 35,000 kilometers or something like that maximum of it or anything like that. So the geosynchronous satellites are like about 35,500 kilometers. So they're quite a ways out. So yeah. So like say ISS about 400. A lot of weather satellites 700, 800 kilometers. You see a lot of information like NOAA satellites. They're 700 kilometers. Now all the pictures you see of like the hurricanes, stuff like that, are all geosynchronous, and NOAA's a National Oceanic and Atmospheric Administration. So NOAA has a lot of geosynchronous satellites that take pictures of the ground in either visible infrared light, stuff like that. So those would be geosynchronous, but they have a lot of non-geosynchronous. So there are other orbits. We can talk about orbits all day long. I love to talk about this stuff. Anyway, so in this case, this is one of the satellites which might have re-entered and hit like in that Spain. And I don't know if I mentioned there was another one shortly after that that hit in Mongolia. So it was U.S. satellites, we put them up, and one hit in Spain in 2015, I think it was, right? And then one hit in Mongolia in 2017 or 2016, something like that. But if you look at a lot of these, the perigee is typically very low in the southern hemisphere, which is almost all water. And so this is one example. I did a big analysis of it, with this guy, Joe Remus, who lives in France, helped me out. And so I've written a series of stories, 10 of these, for this one Space Review webpage. This guy, Jim Faust, runs that. And so I put an article, one of my 10 articles about these houses. It's not going to be a real problem in general unless you have a fishing boat and some big piece of junk hits your boat. You know what I mean? So a lot of these satellites are ones that impact in the southern hemisphere. Okay, next. Any IT guys? This
Oh,
next.
that was some bank information.
So blah 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 blah. I talk about what I do and why you do. So you got questions about that? Okay, so satellites to the ground. We don't tell somebody, and there are some, not a lot, some cases where we don't. I think it's changed. Okay, so how do you do it? And I decided when I wanted to do this several years ago that I was gonna try to get inexpensive hardware, software, firmware, something like that in the name, The bad news is it took me a long time to figure stuff out. I made all kind of mistakes. So I have a program on my phone, and there's many of them, that shows you like the Earth's equator, there's a horizon, here's the sun going down, and you can look at all the constellations. So Orbit Track. It's written by a guy, I sort of I've talked to him many times on email. He lives in the San Francisco area. So Orbit Track, so we can find one. There we go. Yeah, I'll show you in a couple of seconds here, but if you can see my phone, I don't have a picture on the slide, I probably should add one. Orbit Track, like several of these programs, produces an image of the sky above us and this green line. If you got to exclude a little bit, I'll already joked in the phone later on, a green line, which is the predicted path of the satellite. Okay? And don't laugh when I tell you this, but so I have my camera, and actually I hold it against the back of the camera and change it, swing it around like this to point at so I have the green line in the camera. It's kind of crude, but it works, So I wanted to get a very good camera with their good optics, So we got a night. I got this a used night I sold here a couple months ago. You can buy lots of really, very high quality cameras cheap, Anyway, so I use this Orbit Track application on the phone to figure out, to look ahead for the night to see what's going to be up in the space and going by, stuff like that. So I get a little list of newspaper, and I actually put the camera out either in my driveway, I live right across the street almost over here, or generally in the wintertime, if in the summertime, I'm just going to get one picture, one satellite per night, or just got to get my skills going. In the wintertime, I want to get more, I have to track the NOS satellites and look for a lot of other satellites too. So in my neighborhood, there's a little baseball field, so I run out in a baseball field. I actually set up on a pitcher's mound and take pictures there, because there, of course, in my driveway, I get these big honking houses and trees and stuff like that, you know what I mean? So this is not a good, I can get stuff if they're coming right over the house, basically, right near zenith. But so in the wintertime, so I wait until, so I look at my phone, I get a list of what's coming up, grab my camera, and this is exactly what I use right here. One thing, it says set camera time, and if we talk about this sometime, that it is remarkably difficult. So I need time that's accurate to like hundredths of a second, even better, because satellite travel at 17,500 miles an hour, when they're at low orbit, like ISS is, you know what I mean? So you take a picture, and if your right ascension and declination are off by tenths of a second, then your location is wrong. So you'd be surprised how difficult it is to get the exact time. I looked around quite a bit, talked to a bunch of people. I actually have an app on my telephone. I think gives me the best time. Like I've looked at both PCs. I'm a Mac guy, but if you look at the time on PCs and Macs, it can be off by tenths of a second. That computers are, that we use, that's accurate enough. There's probably somebody I'd like to find that does. There must be somebody that really needs to know the exact time. I got to talk to that person sometime. I'm about as close as I got so far. But anyway, so set camera time has really been a very difficult process. Anyway, so I actually have a web page that says how to do that. Okay, next please. So wait for clear air, which is rare around here, as you all know. On the backside of a cold front's always good. You know, the nice cold front in the wintertime, go about them through, you know, the air is dry, the humidity drops down. Unfortunately, the baseball field is wet in May, because it just rained. So, always wear big boots, stuff like that, you know what I mean? But we had this hot, dry with a drought, and actually got a bunch of good pictures this summer, you know, during the drought, because the air is like 170 degrees during the day, air is dry, you know, stuff like that. So set accurate time and go that. I actually get the time shown up here, and I get this app on a telephone, probably called Time, which displays the time, and I hold like this, and I set it and I go and set it. And I practiced a lot, I mean, really a lot. I'm fairly good at it now, but I wasn't for a long time, you know. I have actually connected my camera to the computer, and I can sync the time on that, you know what I mean? But I've been doing a bit of an experiment. What I actually do right now is I have been taking pictures of the camera, or taking pictures of the phone from the camera, and trying to figure out what is there a sort of trying to calibrate the camera. I think the pictures are off by about 0.22 seconds. I don't know why, but I thought with a quality camera, this thing supposedly has a shutter speed of like 1/8,000th of a second. I thought that a camera would be very good, have an accurate clock, but it doesn't, you know what I mean? And like I say, computers, you know, can be very inaccurate as well, whatever. So, set accurate time, run out to the baseball field, point my camera, and then I set it up at a 2-second delay to avoid, to let vibrations stamp out, and take 10-second exposures, okay? And I usually take like a bunch of pictures in a row, because sometimes satellite's a bit early, a bit late, so like that. Okay, here comes another piece of software. Do you all know, we're going to do that all photos have this stuff called EXIF information. So like if you get all these pictures from like your iPhones or, you know, other type of smartphones or even a lot of cameras, like this is a GPS module, not very handy. But so any of the pictures you get from digital cameras or certainly any smartphones, it encodes the exact time, you know, the latitude, longitude, stuff like that. So people have been actually surprised that they've, you know, people thought they're going to get away with it, like emailing pictures to people, you know, of something. They didn't know there was this EXIF data. So you could like pull up with an EXIF reader and get all that information. Somebody, you know, people sent, you know, pictures of this, you know, stuff, and then they didn't know they could read the latitude and longitude they get at the time to see where the person was who took the picture. So, you know, digital photography is wonderful, but it has some, you know, some things you gotta know. So anyway, there's EXIF tool, different as software, you can read all that information from any picture you take. Okay, now I don't have a lot of time, but I have to go to astrometry.net and submit the picture, and it resolves it, and I'll show you what I get in a couple seconds here. So you take a photograph, get an image, stick it in astrometry, you get another file back, then you put it into SAO image DS9, and then you produce what's called observations. You know, those are update the orbital parameters. Next. So this is what I get all the time, and we could probably dim the lights a little bit. You can probably see it fairly well.
That's it. That's as slow as they go.
And so you can like turn them off or whatever.
No, those are the.
I can move the screen
Well,
brightness up. Maybe that'll help.
if you need to, we can go up and see. But so the result I get is, you know, these are various stars, obviously, and there's the streak of a satellite going by. So I've chosen 10 seconds. There's this thing called rule of 5 or something like that. So if you're taking pictures of the stars, there's some streaking of the stars as it's the sidereal rate, you know, the Earth rotates, something like that. So about 10 seconds is about as long a photograph you can take without these stars getting too streaked. So I stick this into astrometry, and and it figures out exactly where this is. And then that SAO image DS9, I can tell the right ascension declination for any point, like the stars, or the end, both ends of that streak. So I know the camera records the time the shutter opens. So if I know it's not going this way, I know time, right ascension, and declination for that point. So that's an observation, and I get the other one. I could kind of wag the middle of it, get 5 seconds, you know what I mean, but, you know. Next.
Is that zoomed in at all? Is that?
No. Yeah, so are you saying, do I use like a zoom
Do
lens?
you zoom in or?
No, this is a 50 millimeter fixed focal length lens.
Oh, fixed focal.
It turns, for the ones that I want, I need wide field of view, right? Because by using this very cheesy method, I can take pictures, but I don't know where exactly in the picture the satellite will be. So it isn't, what I need, I'll have systems where they have telescopes with computer drives and things. You can actually put these orbital parameters in, it'll drive the telescope or camera to that right ascension declination to get pictures. If the seeing was better, if I could do more, track more, I might actually invest money, but I mean, I'd invest, several $1,000s to get a few pictures, and it's not worth it to me yet, Though I know people, of course, the real smart people have these ZWO video cameras. The real smart guys have these video cameras and GPS time inserters and things. They can actually get a video and they can print off the individual snapshots, images from it with an exact time on it. So, my system works. Okay, so that one is a very bright satellite. You can't see it too well. This is more typical, and you can take a look at it if you want to. Doing this weird hobby, you can really wear your eyes out. Sitting in the dark in your office, at the computer, looking for a streak like this here. And that's a Chinese upper stage right there. Like that. I have pictures of lots of satellites. So each individual image, not very exciting. Okay. The interesting part is that, from this you can get time, right ascension declination from each end and send it off, and there's actually probably like 70, 80 satellites right now that we typically track, and they're from various countries and stuff like that. I think that's the last one. I think one more here. So I'm out here. If somebody wants to talk about orbital mechanics or orbital parameters, I talk about inclination. Here's the Earth. Here's an angle inclination between the Earth's equatorial plane and the plane of the satellite's orbit. Perigee is low point, apogee and high point. Stuff like that there, So anyway, so that's really it. The one thing I said, I actually got on the front page 2 years ago of the Houston Chronicle, they did a story about me, and it has a bit more information. And that's nice, my moment of fame, right? So, okay, so that's really it. Any other questions at all?
Did you modify your camera any, or is that just?
It's just
right out of the
straight
box?
stock.
Wow.
No modification. So yeah. There's a lot of stuff that I would like to do if I had a more accurate way of pointing it. I would think about trying to buy a fixed focal length to be a longer, not a zoom lens, because zoom lenses are very what's called slow. They absorb a lot of light. I need bright. Like I use I don't know if you know about photography, ISO like 400, which is fairly high ISO. You can never take pictures during the daytime with ISO 400, and f-stop about 2, which is pretty wide open.
Yeah.
So I really need a lot of brightness, even though I'm going after very bright satellites personally. So if I went over after dimmer satellites that were like higher off the ground, I would need something like a real telescope, or and something which really points it very accurately, and then I could be able to possibly maybe like a 70-75 millimeter lens, fixed focal length. Because again, it's a very fast lens, but those fast lenses can be pretty expensive too. So I just really haven't, like I said, the most stuff I do is analytical, so, I just do, I wanted to take pictures and submit observations, and it was kind of an intellectual challenge, which it really took me probably, especially since I couldn't actually take pictures in the summertime most of the time. It really took me 2 years for really figure this all out.
What happened to all the iridium flares? I haven't seen those in a while.
I guess there's actually a lot of people are upset about not so much iridium, but also like the Starlink, stuff like that, how bright those things are. So they've really worked very hard on making the satellites not as bright by, angling them the right way, something like that. I think the iridiums, they would flare because they were under like absolute control, and they eventually get some specular reflections off of them.
Yeah.
But those that did flare, most of those are all dead, and so they tumble. And so you can still get a flare off them, but it's only microseconds. So.
I've seen tumbling satellites too.
Oh, yeah.
Yeah.
Yeah, a lot of times if you look back on the pictures I had to go take a look at them, I've looked at them really closely and probably nearly ruined that. One more back. You can see that the brightness, this is obviously a satellite that's under control, under adjunct control. Because the brightness is so uniform. But you can see in the pictures where they're brighter, dimmer, even within 10 seconds. So
Trying to figure out if that's Gemini, if that's Pollux and Castor up there.
A lot of the pictures I get do typically are in those constellations. I would have to look a little bit and see. When you do astrometry, it immediately pulls up all a big map of all constellations, stuff like that. But a lot of times what I try to do is when I point my camera is really have a guide star, and of course the Orion's belt's perfect, stuff like that, There's a lot of satellites that are Fomalhaut, and things like that, So there's a lot of, very bright stars, which are very good, bright guide stars. You can actually see them through the camera, So I don't know what constellation it is, but, the astrometry will give you that all the time. Well, anyway, if you're real interested, like I say, I actually have my brief moment of history when I was on the front page of the Chronicle, and it shows a picture of me, and you can actually see the picture on the computer at home of the SAO image DS9, where you can get the right ascension declination. So, like I say, probably the fun and/or frustrating part of this was trying to get, figure out this EXIF tool stuff, and figure out Smithsonian SAO image DS9, and also figure out how do you get the accurate time, and get an app for your phone and that, and how to put in the camera, and just surprising that some of this stuff, especially in this area, you think that, hey, like all of your neighbors would know all this stuff, but you'd be surprised. Okay, if you have any questions, let Aaron know, and I can.
I got your thing right here. Do you have to subscribe to Houston Chronicle to see the articles?
For this one, yeah, but all under paywall. I had a paywall, But fortunately, they sent me a PDF version, so.
Nice. Yeah, that was cool.
Yeah. Anyway, so you're, it looks like come out sometime at night, and I'll show you how to do this or whatever, or.
Are we gonna do it tonight or no?
No, it's too cloudy tonight, so, yeah.
Have you seen Tiangong yet?
I know I've seen a bunch of like the space stations and stuff like that. In fact, it was funny the one night when who was the lady that did this? Andrea Leinfelder came by. Was what a coincidence? Coincidences do happen. ISS happened to be flying over, and I got a picture of it with my camera. and I showed it to her and her photographer, you know what I mean? But I'm actually, ISS, I've got a few pictures of it, but it's not interested. The Chinese space station, a lot of, there's lots and lots of satellites that you can get from the satellite catalog. They're, I can't pop off, which are just not very interesting. So I haven't bothered to take pictures of them, This is my little thing. I think this one broke, but I always have a little clip. I always write the satellites I'm going after that night on a piece of paper and have this little clip, and I clip it on here, and it goes, look,
Yeah, I didn't even know China had a space station until I saw it.
Oh,
I
yeah?
was like, it was like super bright,
Mhm.
and I was like, what is that? So I opened up Heavens Above real quick.
Oh, yeah, and then I
opened up.
flipped it up there, and there was a Chinese space station.
Yeah.
So, yeah. Yeah, a lot of, the Soviets, Russians had a space station. They claim they're gonna launch another space station now, China has a space station. Of course, the International Space Station has a big Canadian part of it, Japanese part, so a lot of people on ISS. Okay, well, it's great talking to you. If you have any questions, let me know.
Thank you so much.
Anybody have anything?
Aside from if he needs help with any of the web pages he's been doing, I can help him out. That's really it.
Cut that live, I guess. Thank you so much, sir.
Well, you're welcome. I really enjoyed talking about this. You
Yeah.
can probably tell, so.